Welcome to Rocky Broad Solar, where we encourage you to make the current flow. On today's episode, we're going to talk about Enphase CT installation. Whatever you do, don't screw up the Enphase CT installation. Let's get into it. I just can't stress how critical this is. If you're an installer out there and you can master all these techniques, you will be worth your weight in gold. I would say 90% of the solar installers out there don't understand all of the fundamentals we're talking about today. And if you can master these fundamentals of CT installation, you are going to be the cream of the crop. So for those of you that don't know, a CT is also known as a current transformer. This is a circular unit that measures current coming through wires. The CTs are the lifeblood of your storage system. This is what tells the storage system what is going on in your home, where the power is going, and what it needs to do. If you screw up the CT installation, it's going to wreak havoc on your system. Nothing's going to operate correctly. You're not going to have accurate data, and the system is just going to fail to meet expectations. So with Enphase, you've got many CTs. They're all manually installed. This is a relatively difficult system to install from an installer's perspective, and the CTs are the #1 failure point in the installation. So you have to have attention to detail and take this seriously if you want the system to succeed. So for Enphase consumption CTs, you always need these on the line side of all home loads. They also need to be on the line side of the Enphase system. So on the line side of all home loads, on the line side of the batteries, on the line side of the PV, right? It needs to measure what's coming in from the grid. It needs to measure what's going out from the grid. This is very important. If you maybe connect via a line side tap or something like that, your CTs have to be on the line side of the tap between the utility and anything else in the home. Super critical. The consumption CT arrows need to face the loads away from the grid. All right, next you've got the Enphase production CT. This is what measures the PV power coming from the microinverters to the system. You got one single production CT. It is a solid core CT. It does not open and close. That's because it has revenue grade monitoring. It's a very accurate CT. It needs to be on the L1 of the PV branch circuits. So all of your Enphase microinverters need to run through that CT, only the L1 phase. The arrow needs to point towards the loads, away from the PV. Next, you've got your battery CT. This is pertaining to the IQ Battery 5P series. That's kind of the Enphase battery that's currently being installed and has been for some time. You got one single battery CT. It has to be installed on the L2 of the battery circuit. So line 2, battery circuit, arrows need to face the loads away from the battery. Seems like we're getting this reoccurring thing. The arrows need to face towards the loads away from the power source that you're measuring. Next, you've got the CT wiring. Now, current generation of Enphase CTs are color-coded, which is a great improvement compared to just getting a whole bunch of blue and white CTs, because now it's very, once you pull that CT wire from their CT locations back to the IQ combiner, it's really easy to get mixed up. If you didn't pre-mark your CTs at both ends before you pulled wire, you just had a bunch of blue and white CT wires over there in the combiner, it's very easy to get it mixed up and plug the wrong CTs in the wrong location. Today, Enphase CTs come color-coded, so no single CT has the same color code, and it makes it easier for you to keep track of which one needs to be on L2, which one needs to be on L1, things of that nature, which one's going to the battery, which one's going to the consumption. So the color code wiring has to be correct. Switching the colored wires in the terminals on a single CT is the same as pointing the CT in the wrong direction. That is known as reversed polarity. That is going to give you negative readings. Next, you never want to cut the factory CT wiring, right? If you've got a CT, I can't remember the Enphase CTs, maybe they come with 5 feet of CT wiring, right? A lot of people just want to run the CTs, pull the wire, you got a whole bunch of CT wiring. A lot of people just want to cut that and throw it away, terminate it just like you would any other, current carrying circuit. Well, that's going to completely screw up the readings of the CTs. You never want to cut the factory CT wiring short. That's because that CT is calibrated to have a very specific amount of resistance. We're here measuring like milliamps coming out of that wire. You do not want to cut the CT short. It'll reduce the resistance and screw up the readings. Don't do it. Next, only extend CTs using twisted shielded. In this case, 300 volt rated. That's because the Enphase system is a AC coupled microinverters. Generally you're working with 240 volt or below circuits. So that CT wiring needs to be rated to the same voltage as the conductors it's running with. In this case, that's 300 volt CT wiring. This stuff is relatively expensive. You can't just go pick it up at the warehouse or a supply store down the road. So a lot of installers get out there, they realize they need to extend the CTs. They do not have the proper CT extension wiring, and they just try to rig something up. Maybe they cut up some old CTs they had in the van, or they just try to run some Romex or THHN. Maybe they'll try to use Ethernet cable, which is a very small wire. Usually it's like 24 gauge. This CT extension cable, it also needs to be a bare minimum of 18 gauge wire, right? And again, if you put too small a wire, it increases resistance. It screws up those readings. So again, twisted, shielded, that's a metal shield that protects the conductor from interference from current carrying conductors, 300 volt rated, and again, minimum of 18 gauge. Now, if you have an extra long run, I think it's over 164 feet, that's pretty rare, but in some cases you may have to extend CTs further. You're going to want to make that wire even larger, maybe up to 16 gauge. Also, although you're using that shielded wiring, you do not want to ground the shield when you're extending consumption CTs. So that's also very important. You want it twisted and shielded, but you do not want to ground the shield as you would on other systems that you may be used to using shielded wiring on. Phase alignment. Phase alignment is just critical. This is where most people just completely fail. Installers just want to say, well, hey, let's put the CTs over there. Let's point the arrows in the right direction. Great, we're done. That couldn't be further from the truth. When you install a CT and you point the arrow in the right direction, and you terminate the wiring correctly, you're still at a 50% chance that you failed to install it correctly. And that is because it needs to be on the phase that it's required to be on, right? And for a normal residential service, you've got 2 hot legs coming into your home, L1 and L2. Most electricians, right, it doesn't really matter. It's just it's 2 hot wires and a ground and a neutral. If you bring those wires into your home and you feed a sub panel somewhere else, it doesn't matter if you cross L1 and L2. It really doesn't matter. It's just 2 hot wires. When it comes to solar and storage and CTs, that couldn't be further from the truth. You need to carefully keep track of line 1 and line 2 all the way through your entire home, from the time it enters from the meter and through to any panels in your home, through all of your Enphase system, through any of your PV, your storage. You cannot get L1 and L2 mixed up, or it's going to wreak havoc on your system and it's going to fail to function. It's going to fail to read correctly. L1 and L2 consistent through the entire system, and we're going to go over this a little bit further in the video. Next, we've got generators. The IQ System Controller 3G is a generator compatible controller. It uses that third DER port and it swaps it out for a generator port. Now when you install a generator with the Enphase system, you need to install a parallel set of consumption CTs with those existing consumption CTs. You need to face them towards the loads away from the generator on that generator circuit. Again, you got to make sure the L1 generator CT is paralleled with the L1 consumption CT. The L2 generator CT is paralleled with the L2 consumption CT. One thing, Enphase, it's not compatible with all generators, right? You can't just hook up a portable generator to this system and think you're going to be okay. That is not what this is created for. It has to be on the approved list of Enphase generators. This is a very short list, and there are very specific sizing guidelines. Dependent on the size of your system, the generator has to not only be on the approved list, it has to fall within these specific sizing guidelines in order to integrate it into your Enphase system. Generally, that's going to be a whole home type of generator. Split systems. Everybody knows I cannot stand the split system configuration. Sometimes it just can't be avoided. When you run into a split system or an existing PV system or integrating a new Enphase storage system into the system, right? This adds a lot of complexity, and you have to get this right. It's got a huge failure rate as far as installers getting this right. So when you've got an existing system or a separate grid-tied system on the same service as the Enphase storage system, you kind of have two configurations. First, if the existing system or the grid-tied system is on the line side of the consumption CTs, then nothing else is needed. This is your best scenario. That is, say, like the grid-tied system is a line side tapped on the line side of all home loads, solar and storage, and then you can land your Enphase storage system CTs downstream of that split system. Then you don't have to deal with installing more CTs. Now, when that existing system or grid-tied system is on the load side of the consumption CTs, now all of a sudden, again, we got to parallel an additional set of consumption CTs facing the loads away from the split system or away from the existing system. So I've created this diagram to simplify this system to the best of my ability. But as you can see, we've got a lot going on here. We've got a lot to keep track of. And again, that's why I would say this system is relatively difficult because of all those manually installed CTs. To simplify it, I'm not showing the two separate CT wires, but again, you have to keep track of the colors of the pair of CT wires. They have to terminate in the correct ports. I didn't have those specific colors, so I just made up these generic single color codes to be able to keep track with everything we've got going on here. So again, you're going to have L1 and L2 coming down from your PV branch circuits. In the combiner, the top branch breaker port is L1. The lower branch breaker is L2. Now, be aware of that IQ gateway breaker. That's switched up. But essentially, right, you're going to run your L1 from the PV branches down through your production CT or your PV CT, and then up through terminating into your branch circuit so that the arrow is pointing away from the PV towards the loads. Next, you've got your feed-through lugs from the IQ combiner. Your L1 is on the left, your L2 is on the right. That's going to come over here to your IQ system controller. It's going to land in those PV ports. Forgive me, my black marker is running out of ink, but you'll see along these DER ports, L1 is going to be on the left, L2 is going to be on the right. So your PV is in the middle there. You're going to land your L1 and your L2. Now there's some factory installed wiring in here that's going to circle around and land into the breakers for the PV battery and DER ports. I'm just not going to include this in the diagram because for the sake of this video, I'm just trying to make it as simple as possible. Okay, next you got your IQ battery 5P, right? You got to land your black in the L1, red in the L2. Keep track of those phases. Make sure L1 from the battery lands in L1 in the battery port here in the IQ system controller. Same for L2. Your battery CT, your 5P battery CT, is going to be in the C3 port, and that is going to be on the L2 phase of your 5P with the arrow facing towards the loads away from the battery. DER port is going to be the same, whether that's for a generator, whether that's for additional PV, whether it's for additional battery. L1 and L2 are in the same position. Again, if it's a generator, you're going to have to parallel a set of consumption CTs there in CT1 and 2, and you're going to have to capture that generator circuit with both an L1 and an L2 CT on both phases of the generator circuit facing towards loads away from the generator. Right, now we've got again, right? So this is partial home backup, so this is probably the more difficult scenario, right? We've got L1 and L2 coming in from the utility. It really doesn't matter which one. We don't care what color it is. We don't care what side it is. All we care about is what phase it's on, and that it's on the same phase as the L1s through the entire system. So again, C1 is going to be your L1 CT. You're going to land it on the line side of all home loads, solar and storage. You're going to point it towards the loads away from the grid. Your L2 CT is going to be over there in that C2 port on the L2 conductor pointing towards the loads away from the grid. Now, beware of Eaton CSR breakers. I also think there may be a few other manufacturers out there on the market over the years where they actually cross phases inside of the breaker. So if you have a breaker here and you got L2 coming in the top, it might be on the opposite side of the breaker coming out. For the sake of this video, we're not going to include the Eaton CSR breakers, but just know that they cross phases. So if you're replacing in here, you can add Eaton CSR breakers for the input or the output, right? That is going to swap phases. So your L2 and L1 are going to be the opposite sides. And you have to keep track of this, and you cannot screw it up. In a standard load center, your L1s and L2s are going to alternate across the bus bar on the way down. So I've tried to illustrate that here in black and red, right? Your L2 is going to go down. It's going to connect to every other bus, L1, right? And what we want to know is, right, that the lug here that is connecting to this bus bar is in fact on the L1 phase, and it's on the same phase as this conductor up here that we have our L1 CT on. Right, so in this case, with no Eaton main breaker, we've got L1 on the right, L2 on the left. For the load output, we've got L1 on the left, L2 on the right. So, as I said, you need to carefully keep track of this during the installation, during the wire of the entire system. But then when you're finished, you need to verify. Trust but verify, right? And the way you do that is with a voltmeter. If you are a solar installer out there, having a voltmeter, a good quality voltmeter on site is critical to your success and your safety. This is Klein. I love Klein personally. You know, I feel like this one was a little over $100 or $150. I'll link it down in the description below. Okay, so for a residential 120, 240 volt service, each phase is out of phase 240 volts, right? So if you're on different phases, you're going to have 240 volts. If you're on the same phase, you're going to have 0 volts. So you're going to take your voltmeter, you're going to turn it to volts, alternating current. That's with the little squiggly line there. You're going to take your probes. You know, usually I'll just go hang this on a wire somewhere or whatever. I don't have a way to do that. But essentially, just pretend I'm doing that. And I'm going to take my leads, right? And we're just going to pick a point of reference, right? To me, the best point of reference is the L1 lug coming into the IQ system controller, right? That's our point of reference. It doesn't matter what color the wire is, if it's on the right or the left or whatever. Whatever wire is coming into that IQ system controller, landing on L1, we're telling the system that is L1. Any wire on a different phase is L2. So we're going to take one lead, we're going to put it there. We're going to find our L1 consumption CT that came out of C1. We're going to land the other one right there. We want to see 0 volts. Right? We're going to just check L2. We want to see 240 volts. We can check our, in this case, we connected with the breaker. Sometimes it's feed-through lug, sometimes it's a tap, whatever, right? 0 volts. We want to make sure that the L1 from the branch breaker feeds L1 in the system controller, right? We want to test the backup load panel, 0 volts. We want to test the L1s on the battery, PV, and DER ports, 0 volts. L1 on this, 0 volts, right? We want to come over here to the battery. We got 0 volts, L1 to L1. We want to come over in your IQ combiner, check the L1 circuits running through the production CT. We want to make sure we have 0 volts. 0 volts, right? I can't stress this enough. Check L1 through the entire system. We want 0 volts between all L1s, 0 volts between all L2s. That means you're on the correct phase, that if any point you're between two L1 lugs and you get 240 volts, that means you have cross phases and you need to correct it. So a problem that a lot of people are going to run into is that, you know, equipment can be located right next to each other. Maybe it's 10 feet apart, maybe it's 50 feet apart. And if you're just a guy with a voltmeter and your arm and your voltmeter leads aren't 50 feet long, that can make this verification process difficult. Well, guess what? There's a simple solution to that. Get yourself a piece of wire that will extend the leads as far as you need to take them. You're going to take those leads and you're going to land them in a wire nut. Next, you're going to take a zip tie. You're going to wrap it around. Maybe even a couple zip ties, right? You do not want this to come loose. You're going to secure that down nice and tight, right? You got a zip tie, you got your wire nut. Lastly, you're going to put some electrical tape around it. Now we've got a nice solid connection. We know this is not going to come loose on us. So if you're lucky enough to be with a helper, you can just hand your helper this in, say, hey, go hold this on the L1 lug in the IQ system controller. They can be holding it there. You could just be walking around with your trusty voltmeter throughout the property, throughout the system, checking all the L1s. 0 volts, 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 0 volts. All right, great. Our phases are aligned. Well, crap, let's say your helper called in sick that day and you're just out there by yourself. How are you going to pull this off, right? Well, that's not a problem either. So what you do is you take this wire and you land it in a circuit breaker. Maybe there's a spare in the client's panel. Maybe you've got one on the truck. You're just going to land it in the L1 terminal of the circuit breaker. You're going to come over here. You're going to find an L1 on the bus, right, that you've got 0 volts to. You're going to land your circuit breaker in the panel, right? Now we know we've got a perfect point of reference for L1. That breaker is going to be there in the panel. And again, you can just walk around the property checking that we've got 0 volts to every L1 in the system. All right, so real quick, I'm just going to show you a real live example here, right? Let's pretend we're going to call black L1 and red L2 in this panel. All right, so we got our handy voltmeter here. I'm not sure if you can see the screen on it. Currently says 0 because I'm on nothing. L1 to L1, 0 volts. 0 volts. L1 to L1. L1 to L2, 243, right? Most systems are off by a couple volts, but it's essentially 240 volts. We go all the way down. Let's say this feed-through lug kit is feeding our IQ system controller, right? This applies to any storage system. It's not just Enphase. This is across the board. This could feed any microgrid interconnect device on the market. Any inverter that installs CTs, this is relevant to all of these systems. All right, so we're on L1. Let's go to L1 feeding our MID. Well, crap, I see 243 volts, right? That means when somebody wired this up, the electrician that wired up the house originally, whatever, they didn't care about phases because it really just doesn't matter whenever you're not installing consumption CTs. So they just took a black wire and a red wire and ran it over there to feed feed a sub panel, right? And they put black on the L2 phase. So they have crossed phases, right? This is where solar and storage installers are going to get really screwed up when you're working with a bunch of sub panels and things of that nature. You cannot have stuff like this going on. It's going to throw you for a loop and it's going to screw everything up, right? So if I were in this situation, what I'd probably do is just tear that red tape off or whatever. You could unterminate the wires and swap them so that, again, your L1 phase is consistent through the entire system. All right, lastly, for those that may live in areas where there are combo meters, such as California, they're actually more and more prevalent across the world. They're pretty prevalent here in North Carolina, right? Let's pretend you've got a big meter here, utility meter, just short little bus bars that feed your combo meter panel outside, right? Well, you can't fit the CTs in there. The utility's not going to allow you to put them on their side of the meter. You have to put them on the load side of the meter. There's nowhere to install these consumption CTs. What do? Crap. Well, unfortunately, it is going to make your life pretty difficult, right? But this is just so critical. This is the lifeblood of your solar and storage system. There's no getting away from it. You have to do this correctly, and you have to master this stuff if you're going to be in solar and storage for the long term. So, what you do in this case, you know, whatever. I've got L1 is the blacks going all the way down. L2s are the reds going all the way down, right? In this case, luckily they're alternating. In a lot of panels, they're not. You just got blacks and reds all over the place. We do not care what color the wires are, right? We just care that they're on the same phase. So in this case, I've taken some blue tape. I've taken my L2, right? And I put blue tape on every L2 phase, right? Anytime I get 0 volts, it gets a piece of blue tape. You can see down here we got blue tape on the black conductor because that is the L2 phase. All right, so next what you're going to do, you're going to have to group. You're going to have to take all of the branch circuits. You're going to use the sub-feed lugs feeding downstream loads, and you've got to basically group all your L1s and all your L2s together. Obviously, you're going to want to de-energize the service before doing any kind of work like this. In this case, it's live. I'm not actually going to pull all these out and group them because I don't need to. But essentially, right, you would take all of your L2s out of the panel. You'd put them all in one big group. You'd wrap a zip tie around them. You'd tighten it down real nice. You do the same with all your L1s, right? Maybe you've got, you know, you're going to have to make 3 or 4 different bundles in some cases. This can be very difficult and very time consuming, but it's just necessary. So you get all of your L1s and L2s into branch bundles, right? I don't have any Enphase CTs on site today. I do have this set here, but you know, whatever. It's fine for the sake of this video, right? We'll call, we'll say This was a parallel set of L1 CTs. So let's say these are two Enphase CTs. I have taken all the wires, I've paralleled them together, maybe somewhere with a Wago, or maybe I just ran them all the way back to the IQ combiner and landed them both right there in those L1 CT ports. And then I'm going to clamp all the L1 branches, that group that we have zip tied together up here. So again, this is really difficult. It's really time consuming. In this case, I've got some aluminum wire here. It's really short. You know, I can't fit that CT on there. I mean, it just is what it is, right? You may have to extend that. You may have to go over in this panel. For the purpose of this video, I'm not going to do it, right? But what you do, you got a parallel set of CTs. You got them all installed, let's say in this case on the L2 phase. They're running back to the L2 CT port in your Enphase IQ combiner at the IQ gateway built into the bus bar, right? And this is measuring all line 2s on the entire home. Again, this is when you cannot access the service conductors. Normally you could just easily put one single CT up there on your service conductors. So to a lot of people, this may seem excessive for an installation. Most people are just trying to get in there, install it, throw the CTs on, clean up and get out of there. Well, you know, the system's going to malfunction. You could cause permanent damage to the batteries that is not covered under warranty. The homeowner will never see the system perform the way it's expected. You know, you may have to make multiple return trips to try to diagnose things, right? Instead of all that nonsense, just go out there, install the CTs correctly, check that they're all in the right phases, they all have the right polarity, all the wiring is properly terminated in the ports. If you're extending them, that you're using the proper CT extension cable, right? You're not cutting the factory CT wires short. I just can't stress how critical this is. If you're an installer out there and you can master all these techniques, you will be worth your weight in gold. I would say 90% of the solar installers out there don't understand all of the fundamentals we're talking about today. And if you can master these fundamentals of CT installation, you are going to be the cream of the crop. Thanks so much, everyone, for watching. I really appreciate each and every one of you. Till next time, take care. If you're looking for a pressure-free, zero-cost quote to put an Enphase storage system on your home, go ahead down in that description below. Click on that Rocky Broad solar intake form. Take a few minutes to fill out some details about your specific scenario, and I'll get back to you with the zero-cost, pressure-free quote. If you're more of a do-it-yourselfer or an installer out there and you're looking for a great place to order Enphase equipment with dirt cheap prices, go ahead down in that description below. Check out our affiliate links to where you can find great deals on Enphase products. As always, thanks so much each and every one of you for watching. Till next time, take care.